Hey, everybody. I'm hitting the can, which is sparkling water, lemon. All right. Today we're looking at truth tables. So we've seen statements, conditionals, all of these things. We've seen negations, conjunctions, disjunctions, conditional and biconditional. But now we're going to see all of those things in terms of a truth table. I apologize about the color here. My printer is just completely not working, so I had to do this first page in black and white. So first, a truth table is just, for instance, if P stands for well, anything, then not P. So if P is true, then not P is false. If P is false, then not P is true. This is a very simple truth table. The first row shows what happens if P is true. The second row shows what happens if P is false. We have every combination of P and not P. So let's look at an example. If Mario is an athlete as P, then we're going to write the negation truth table for P. That means we're going to write every combination of true and false for P and every resulting combination for not P. And in general, if you've got one variable, you're going to begin with true and then false. If P is true, then not P is false. If P is false, then not P is true. So for this first line, we would have Mario is an athlete. In the second row, Mario is not an athlete. If we put a conjunction, remember, negation is the tilde. A conjunction, that means and it's this tent shape. So say we have two statements, P and Q. P is, I did well in the test. Q is, the test was hard. So P and Q would be, I did well on the test and the test was hard. Notice that this, well, you can't really notice yet. Let's look at a truth table for a conjunction. So now we've got several variables. This is great. We've got P is Helena makes extra money in the summer. Q, Helena works at Schlitterbahn. So we've got our column for P. And now, in order to have all combinations, I'm going to do true, true, false, false for P and true, false for Q. That means I've got true, 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 false, false, true, and false, false, all combinations. If you and two things together, they are only going to be true. The outcome is only true if both are true. So with this and this tent shape, the conjunction, the only option for P and Q to be true is if P and Q are true. That means every other combination, we're going to get false. This is disjunctions. Disjunction is the or, and it's the right side up tent, well, the flipped tent. It looks like a V. So let's let P be, I did well on the test, and Q be, the test was hard. With or, if one or the other or both are true, then the outcome is true. So either one or the other or both original statements are true implies the outcome is true. So here we go. Let's let P be the sky is blue, Q be Antarctica is cold. And we've got P, true, true, false, false, Q, true, false, true, false. And now, if P and Q are true, then certainly or is true. If either one is true, then or is true. Either one is true or is true. If both are false, then or is false. So there's only one way to get false when we put two things together with or. This says conditional. Your notes will be fine. Conditional is if then, and it's indicated by this arrow. Excuse me. If the sky is blue, then Antarctica is cold. This is kind of an interesting thing. So let's look at it. If P is true and Q is true, then the outcome is true. If P is true and Q is false, the outcome is false. However, there's something a little bit weird that happens here. It's called true vacuously. If you assume something false, you're saying if P is false, the outcome is going to be true no matter what. Because if you assume something false is true, then any outcome is true. You get anything you want. And this is called true vacuously. So with implication, with implies, true implies true, true implies true is true, true implies false is false, false implies true. The false premise always leads to a true, false premise always leads to a true premise. That's the if. I think it's an S. Okay. Biconditional, that's the if and only if. And it's indicated by the double arrow. If and only if is true when P and Q have the same truth value. That means if both P and Q are true, P if and only if Q is true. If both P and Q are false, P if and only if Q is true. But if they're mixed, then P if and only if Q is false. So the biconditional connector, the double if and only if, double arrow, is true whenever P and Q are the same. They're both true, they're both false, we get a true. If one is true and one is false, we get a false. Now we have everything that we need to do some kind of fun problems. We are now going to be constructing truth tables. So what in the heck does that mean? Well, let's construct it. I'm going to show you by example. That's the easiest way. I want to see if what the truth table is, the truth value is for P and Q. Remember, the tint is and, the V shape is or, and the double arrow is if and only if. So we've got P and Q, if and only if P or not Q or not P. This is the pattern we always start with. We have, if we just have two variables, we do true, true, false, false for the first one, and we alternate for the second, true, false, true, false. That gives us our first two columns. Now we want to see, where are we trying to go? I know that one of the things I need is P and Q. So that's my next column. That's the next column I'm going to make. I have true, true. If you and two things together, they have to both be true in order for the outcome to be true. That means every other combination is going to be false. I also need a not P in here. So I'm going to take P and change all of the truth values. True becomes false. True becomes false. False becomes true. Now it's easier for me to consider Q or not P. So these two columns are the ones I'm looking at. And with or, if at least one of them is true, the outcome is true. So let's see, true or false, that's true. False or false, that's false. True or true, that's true. False or true, that's true. So now we have our two columns that we're going to compare. And remember, with if and only if, with this double-edged arrow, we only get true if the two parts have the same truth value, both true or both false. So let's see, here they're both true, so that's true. Here they're both false, so that's true. Here one is true, but one is false, so that's false. If they're different, the answer is false. Here one is false, the other is true, so that's false. So our truth table for this question is true, true, false, false. So if P is true and Q is true, then this whole combination of stuff is true. If P is true and Q is false, we still get a true. If P is false and Q is true, we get a false. If P is false and Q is false, we get a false. Well, here's an even more enjoyable problem. P or Q and Q or P. Is that what I wanted? Yes, I guess so. So P or Q and Q and P. So we always begin, if we only have two variables, we begin with true, true, false, false for the P and true, false for the Q. That gives me my first two columns. And now let's see what we need. We need P or Q. So that's the next column. Or is going to be true if at least one of the others is true. So let's see, true, true is going to be true. True, false, that'll be true. False, true, that'll be true. False, false, if we have both falses and we're oring them together, that's false. The other thing we needed was Q and P. So Q and P, that's only going to be true if both of Q and P are true. So we have true, true is going to be true. And all of the other combinations, there's at least one false. And so every other combination is false. Now we're going to consider these two columns and we're anding them together. That means the only way to get a true is if both match and they're both true. So we have true and true is true. True and false is false. True and false is false. False and false is false. Well, let's throw in another variable. What happens if you have Q implies P or not R? What in the world? Well, now we've got three variables that we're considering. In order to have all combinations of trues and falses, we're going to do this pattern. For P, we're going to do true, 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 false, 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 false. For Q, we're going to do true, true, false, false, true, true, false, false. And then for R, true, false, true, false, true, false, true, false. And we end up with the first three columns. Well, the first thing we're going to do is add to those three columns. One of the things we need is P implies Q. Q implies P. Remember that the only way to get a false answer is if Q is true and P is false. So the only way to get false is if Q is true and P is false. That's for this column. So let's see, we've got true, true, that's true. True implies true is true. False implies true. That's the vacuous case. We're assuming something false. That means the outcome is true. Assuming something false, the outcome is true. True implies false, that's false. True implies false, that's false. False implies false. We have a false assumption, so it doesn't matter what happens, our outcome is true because we've assumed something false is true. And then false implies false is also true. So the only way to get false when you have implies is if the first one, and in this case it's Q, the first one is true and it implies something false. Not R is going to be exactly opposite of R. So R was true, false, true, false, true, false, true, false. Not R or tilde R. This symbol is called tilde. Tilde R will be false, true, false, true, false, true, false, true. And now we have what we need. We've got these last two columns and we're ORing them together. Or that means if at least one of them is true, the outcome is true. So let's see. True or false, that's true. True or true is true. True or false, at least one is true, so that's true. True or true, that's true. False or false, there we go, that's a false. False or true, true. True or false, true. True or true, true. Let's do one more of these, and then I want to do something online in Connect Math so that you can sort of see what it looks like on Connect Math. So let's now construct a truth table for R and Q or P and Q. Again, we've got true, 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 false, 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 false for P. True, true, false, false, true, true, false, false for Q, and then alternating true, false, true, false, true, false, true, false for R. We need R and Q. So here's R and Q. Remember, when we AND two things together, in order to get true, they both have to be true. So here we go. True, true is true. True and false is false. False and true, false. False and false is false. True and true, there's another true. True and false, false. False and true, false. False and false is false. Now let's look at P and Q. So we're going to look at the first two columns. And the only way to get true is if both P and Q are true. So here we have true and true, that's true. True and true, that's also true. True and false, that's false. True and false, that's false. And now the rest of P is false, so the rest of P and Q will be false. So we only have two truths in that case. Now we're ORing these two columns together. OR says, if at least one of them is true, the outcome is true. Well, here we go. We've got true or true. That's true. There's at least one true. False or true. That's going to be true. False or false. This is the only time when we get false when we are ORing. False or false. That's also false. True or false. That's true because we have a true. False or false. That's false. False or false. That's false. False or false, that's false. if you look at the notes, I worked out I think 2 complete additional examples that I'd like for you to walk through on your own and ask me about if you have questions. But let's look at one more thing before we go to Connect Math. What if we have a question? We want to consider whether not parentheses P and Q or R is true or false if both P and R are false statements and Q is true. This time we start with a very short truth table. Our 3 columns only have 1 entry. P is false, R is false, and Q is true. So it's a little bit easier to fill out the truth table. The first thing we're going to do is find P and Q. P and Q. Well, let's see. P and Q, they're different, so P and Q is false. Now we need to find not P and Q. Here we go. Not P and Q is opposite of P and Q. P and Q is false, so not P and Q is true. Finally, we're going to look at R and not P and Q. And here R is false, not P and Q is true, and we're ORing them together. With OR, at least one has to be true in order for the outcome to be true, and this time the outcome is true. Well, what if we have a slightly different question? We have Q or P or tilde R, not R. So here, we're assuming, first of all, we're assuming that P and R, again, are false. P and R are false. Q is true. And we want to find, we're going to need to find tilde R. We're going to need to find P or tilde R. And then we're going to find Q or P or tilde R. So let's see. We've got P, Q, and R. Tilde R, since R is false, tilde R is true. Remember that word I'm saying is tilde. That's the name for that symbol. So we've got tilde R is true. Now we're ORing P and tilde R together with OR. If at least one of them is true, the outcome is true. Well, here, tilde R is true. So it doesn't really even matter what P is. The outcome is going to be true. Then finally, we are ORing Q together with what we just found. Well, again, it doesn't even matter what Q is, since P or tilde R is true, and we're ORing 2 things together, at least one true gives us a true outcome. And here we do have both trues. Finally, let's look at, oh, here we go. Let's look at whether or not R and P or Q is true or false if P is Apple builds computers, Q is Apple makes bedspreads, R is Dell does not make computers. Well, this time we have to think about it and determine whether or not P, Q, and R are true or false. Well, Apple does build computers, so P is true. Apple, at least so far, does not make bedspreads, so Q is false. Dell does actually make computers, so R is false. The first thing we want to fill in is P or Q. So here's P or Q, and we're going to look back at P and Q and see if at least one of them is true. One of them is true, P is true. So P or Q is true. And then we're going to add R to that. Remember with and, with the tenth shape, both things have to be true in order for the outcome to be true. Otherwise, the outcome is false. Well, this time we're anding false and true. So the outcome is false. And let's see what that looks like on Connect Math. I'm going to see what happens if I stop sharing and share something else. All right, is this our class? Yes. Okay. So we're looking at 3.2. And some of the questions are weird. So let's just see. Okay, this is what the questions look like. Here we're trying to construct a truth table for tilde Q and P implies tilde P. Well, just like I said, the first thing that we do is construct the first two columns. So P is going to be true, true, false, false. Q is going to be true, false, true, false. That's a convention. It always is used. Now, Connect Math has this little thing. Do you see the plus with a column? I'm going to press on it. And the first thing I need is tilde Q. So I'm going to write tilde. Come on. Oh, does it not let me? Here we go. Tilde. Oh, it doesn't let me put a tilde. How weird. Maybe let's see. Oh, it doesn't let me to do anything. How weird. How very weird. So that's not helpful. I'm going to put, instead of Q, I'm going to put a symbol for, how about NQ? Oh, it does. That's weird. It won't even let me do that. The only letters it lets me put in are P or Q. So in this case, this little thing, I was wondering whether or not it was helpful, but it actually isn't, since we can't construct the actual pieces that we need to create, that we need to construct in order to get the truth of the end. So let's say we have this question. What we're going to do so I've got PQ, P is true, true, false, false. I want you to write this down because I can't show you. So Q is true, false, true, false. The first thing we need is tilde Q. So please write down tilde Q is going to be false, true, false, true. In fact, since we all know what this column represents, let's go ahead and see if it'll let us put false, true, false, true. Now this is so weird. Okay, so the next column is going to be not Q and P. Well, let's see. When you and two things together, we have tilde Q and P. When you and two things together, the only way to get a true is if both things are true. Well, the very first option, remember, we're comparing columns 1 and 3. The first option is false because there's at least one false. The second option is true because both P and not Q are true. The third column is false, third row, pardon me. And the fourth row is false. Now we need tilde P. Let's see, there we go. So this third row column, pardon me, third one is going to be tilde P. And tilde P is exactly opposite of P. Since P is true, true, false, false, tilde P is going to be false, false, true, true. False, false, true, true. Now, let's see, what are we doing? This column that we just filled in is tilde P. Tilde P is what we are going toward. And the assumption column is this, let's see, 1, 2, 3, the fourth column. This is the tilde Q and P column. And with implies, with the arrow, if the beginning part is true, then the final part has to be true. But if the beginning part is false, the answer is true vacuously. So here we're starting with, we're assuming false. That means the outcome is true. Next, we're assuming true, but the answer is false. That's the only way we can get a false. Here we're assuming false, so it doesn't matter what the tilde P is. The answer is true vacuously. And finally, we're assuming false, so the answer is true vacuously. And let's see. We won. Okay, that's fun. Let's do another one. I'm going to write this down and we're going to do it on paper so that I can share my screen again, because I really don't like the interface, but I did want you to see what it is. So we're going to have 8 rows. We're going to have P, Q, R, and then what are we working toward? We want R or Q and R and P. All right, I'm going to stop this share and start the other share so you can see my paper. Okay, so we've got R or Q and R and P. And this is a convention. That means everyone does it in the same way. We start off, when we have 3 variables, we start off with 4 trues for P and then 4 falses for P. Q gets 2 trues, 2 falses, 2 trues, 2 falses. R is alternating true, false, true, false, true, false, true, false. And now I want to look at where we're going. One of the things we need is R or Q. When is R or Q true? Send me a text at 210-861-9934 and tell me when is R or Q true. Plus 5 points. Okay, all right. I'm going to give y'all time to do that. Pause the video, please, and go and text me, and I will happily receive your texts. So now we've got R or Q, and that's right. At least one of them has to be true. Well, if we have true, true, and or is always true. Here we have true or false. There's at least one true, so the answer is true. False or true, the answer is true. False or false, this is the only time we have an outcome of false when we are using or. True or true is true. True or false is true. False or true is true. False or false, that's false. All right, the next thing we need is R or P. R or P. Here we've got R and P. True or true is true. True or false is true. True or true is true. True or false is true. False or true is true. False or false. There we go. Two falses. That's the only time with or that you can get a false. False or true is true, and false or false, that's false. And we only need one more thing. We need the whole combination. So we need these last two columns, and we are anding them together. With and, the only way you can get a true outcome is if both of them are true. So I'm going to put that column here. This is, we're anding the last two columns. True and true, that's going to be true. True and true, that's true. True and true, that's true. False and true, that's false. With and, both of them have to be true. True and true, that's true. False, true and false, that's false. True and true, that's true. And false, that's definitely false. So the way that you would do it in Connect Math is all they care about is this final column. You would just enter true, 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 false, true, false, true, false, and you get 100. I want to try to keep this video short because I know y'all are really aching to get on with things. So I'm going to cut it off here. Please do. I'm looking forward to getting these texts, and I hope y'all are doing great. Bye-bye.